All right, I think we're recording here. I got this camera and I apologize, it doesn't focus very well. Here, let me turn that back on. So anyway, so if you want to take the test today, computer test, you can take it in the testing center today. Save yourself, it'll be free. Tomorrow and Friday, it'll be $4. The written test is tomorrow here. So it's your turn to ask me anything. Taylor.
Can we do 6.1, number 32?
6.1, number 32. Okay. 6.1, number 32. All right. We've got the, here, I'll make this a little bigger here. In the lottery, I'm just going to call it the lottery, Cash Live Lottery. In Connecticut, a payer pays $1 for a ticket with 5 numbers. 5 balls numbered 1 through 35 are randomly chosen on bin without replacement. Okay. If all 5 match, player wins $100,000. Probability of winning equals 1 out of 324, 632. That was nice of them to give you that information. If format, you know what I think I'm going to do? I'm just going to make a table rather than do this. Okay, so so here we go. X. So 5 match. 5 match. And the probability is 1 out of 3, 2, 4, 6, 3, 2. Okay. If 4 match, we need the winnings. The winnings, you win $100,000. If 4 match, then you win $300. And that occurs 1 out of 2164. Oh, shoot. 1. I didn't think that would turn that into a date. 2164. I guess that's coming up. 1 divided by, there we go. If 3 match, player wins $10. And this is 1 out of 75. And that equals. I compute the expected value. Find expected. I'm going to put that up here. Find expected value. That's funny because I thought the way I set this up is really helpful, actually. I was like, this sounds like an expected value problem. Okay. So, how would you figure that out?
What's the probability times the winnings and the amount?
Yes, but we're missing one thing.
Is the chance of like 3 balls matching it essentially inclusive of 4 balls independent? Or like is 3, 4, and 5 independent probabilities, or do they overlap?
Okay, let's think about this for a minute. Are they?
They don't replace them.
They don't replace the balls, so they're technically not independent.
Like if we were to find.
But are they mutually exclusive? Because these are the only ways you can win, right? You get all 5, you get 4, you get 3. Those are all the ways that you can win. How many ways can you lose?
So I guess I'm asking you the like compound, the team matching, one matching, zero matching, yes, as all those abilities.
Yeah, but you don't win with those.
Well, but just making sure we can add them up.
You could add them up, but I don't want to. That actually will make the problem harder. Okay, let's just leave it with what they've got. These are so essentially you've got 3 ways to win, which we've listed, and how many ways do you have to lose? All the rest. And if you lose, how much do you lose? You lose your dollar, right? So I'm going to make that a -1. You lose your dollar that you bet. Okay. What's the probability that you lose your dollar? Which is a good problem. Okay. There's a really nice, easy way to figure this out.
You just
Hiram was thinking the hard way.
You just
Sum up those probabilities. 1 minus the sum of these 3 ways to win, right? Whoops, I forgot my equals. Equals 1 minus the sum of all of those. That's how many, so ooh, yeah, that's right. 98% chance you're going to lose. Right? Does that make sense? Okay. So those are your ways to win. These are your ways to lose, right? Okay. Now I probably could figure out the 0, the 1, the 2, and theoretically it should add up to the same thing. Because those are the ways to lose. That's a good question. So the picking of the balls, the picking of the 5 balls, is that independent or is that dependent? It's certainly dependent because we're not replacing the balls. Okay. But are these independent of each other? Yes, those would be. So it's a little bit hard to answer. Is it independent or dependent? It's kind of a combination of what you're trying to do. So it was really nice that they gave you these 3 probabilities because those are actually pretty hard to figure out. Okay, we could figure them out. Oh, where's Mason? He'd do it for extra credit. Mason, I hope you're listening to this. Somebody tell Mason we talked about him in class today. We're sad we couldn't tease him in person. Okay, it's videotaped for you though. Okay, so at any rate, we've done the hard part now. How do you find the expected value?
Now, is it when you take the probability?
Yeah, so we need the product here. Equals that times that. And we're just going to copy that down. Copy it all the way down. Okay. And then what? Add them up. Okay, so for every dollar ticket that you spend, you should expect to lose 40 cents. But 98.5% of the time, you're going to lose that whole buck. A third of one out of 300,000 times, you'll win $100,000. Okay. Does that make sense? Yes.
Do you have to subtract the $1 that you spent on the ticket?
Well, we did that already, right there. So there is another way to do it, and I don't want to show you that because they show you that in my other Math 1040 class, and I'm like, no, I don't like that way. But that's kind of what they do, and it's not as accurate as this. But yeah, if I subtracted another dollar, then I would lose $1.40, and you can't lose $1.40 on a dollar bet, right? So that, yeah. So yeah, I don't want to show you the other way because it's not as accurate as this. Okay. Any others? Taylor's our question asker today.
It is 7.1, number 8.
Okay, yeah, what problem was this? This was 6.2. Problem 32. Okay, and so now we're going to do, what did you say, 7.1?
7.1, number 18.
Problem 18. 7.1, problem 18 says, oh, we did this one in my other class. Except for it wasn't recorded, so they'll probably appreciate this. The reaction time of chemical, reaction time X of chemical reaction follows a uniform distribution with 5 less than or equal to X less than or equal to 10. A, draw a graph of density curve. B, what is the probability that reaction is 6 to 8 minutes? C, what is the probability that the reaction is 5 to 8 minutes? And D, I'm going to copy this one. What is the probability the reaction is less than 6 minutes? Okay. I probably wouldn't make you draw this on Excel. Although I had a student ask me how to do that, I can show you if you want. This is part A. Oh, by the way, are we sharing? Oh, we haven't been sharing this whole time, dang it. Now we're sharing. Okay.
Could you go back to that other slide real quick, just so
You want to see the other slide?
yeah, just so I can look at
There you are. That's the expected value problem that we just did. That we talked it through, but we didn't see it. So there. Okay. So if you're watching this, hit pause, and then you can figure that out. Okay. All right. So back to here. How do we draw the density curve? Should I stop sharing? Let's stop sharing. Let's draw this on the board. How would you draw that?
Uniform distribution.
Uniform distribution. What kind of a shape is it? It's a rectangle. Okay. It's 5 to 10 minutes, right? How tall is it?
1/5.
1/5. What would we label this?
Reaction time.
So reaction time in minutes. And this would be probability. Thank you. My other class really struggled with that. Okay. Now, if you really had to draw this in Excel, well, now we're out of focus again. There we go. Focus. Screen share. If you really had to draw this in Excel, here's how I'd probably do it. I would say insert, pick a shape here, a line, draw a line like that, grab another line again, draw it like that, grab another line again, here to here, draw another line again, here to here, and probably put a 5 and probably center that there, and put the 10. We call this reaction time in minutes. I would put, well, you could put 0.2 here, I guess. Oh, that was kind of in the wrong spot though. See if that was center. That's good. Call that probability. There you go. Okay, that's pretty good. What is the reaction? What's the probability the reaction is 6 to 8 minutes? How would you figure that out? That might be easier to do on the board. probability that X is less than 6 minutes, is that what I said?
6 to 8.
6 to 8. X is between 6 to 8 minutes. Yeah, you could draw your picture here, right? We've got 6, 8, we want this area here, right? So what's that area? You guys are talking way too soft. Nobody's ever going to hear that on the
2
camera.
times 1/5.
There we go. 2 times 1/5, right? It's 2/5. Okay? Next one says 5 to 8 minutes, right?
Yeah.
Pick another color here. 5 to X. 5 to 8 minutes is going to be this green area here. Okay, so that's going to be
3/5.
3 times 1/5 equals 3/5. And then finally, what the probability that X is less than 6 minutes, right? That's going to be the red area here. And that's going to be 1 times 1/5, which is 1/5. Okay? Colin?
So it's asking about the density curve. That's just asking you to draw a uniform.
Yeah. So we call that a density curve, even though it's not very curvy.
Yeah.
Okay? Yes.
How do we locate the probability on not just?
It's the area of the box. Yeah, to find the probabilities of the area of whatever box you do. So I've got the black, the green, and the red there. Okay? Oh, we're out of time. Okay. All right, well, good luck on the test. See y'all tomorrow here. We'll take it. The computer part's open today, right now. You can go to the testing center now, and the written will be here in class tomorrow. You can take,
When is the written portion close?
the written portion is in class tomorrow. Just
I'm sorry,
the computers today, tomorrow, and Friday. Remember, if you take it Friday, they close early on Friday. So check with the testing center. Don't show up after close.
How many
Yes.
questions are on the computer test?
5, I think. I can't remember. I think it's 5. But they have ABC parts.